to be on this guy. What's our first step? Combining them. Be slightly more specific.
Taking log base of 3 and x and log base of 3, 6, and basically getting rid of one log and putting 6 and x together.
Yes.
At a time.
Because we are going to condense this and our addition becomes multiplication. So our log base 3 stays the same, and then we're going to wind up with x times 6. Our two arguments get multiplied together. Then what will we do? Log base 3 of x times 6. I'm just going to scooch them closer together because they're really spread apart. It's kind of weird. Now we have it as a single log. Say it louder, baby. Switch the forms. So we're going to have our base of 3. That's this guy. Our power of 3, it's that other guy over here. And it's going to equal the 6 times x, or x times 6. Same thing. So we switch the form.
Is this school days left?
Correct. School days left should be 27. Because yesterday counted.
Oh, yeah.
I know we totally all did totally did the assignment.
I did.
I know everybody 100% totally did. I love it. I'm gonna say it's my shocked face that there's wait what?
I got one totally wrong.
It happens. What do we do from here?
I'll show you my math. Wait, how did you use that?
So this first time getting, whoa, sorry, that was not the laser pointer. This first time getting rid of logs here, or this last one that I just got rid of here? The first one. This was using our condensing properties, where we take our addition and make it be multiplication. So since we have an addition between two logs, I can take my two arguments and multiply them together using the condensing properties. On this one, how we got rid of it was we switched it from log form to exponential form with the BPA log BAP thing. When we do condensing, it gets rid of one of the logs.
Okay.
So what can we do from here? Oh, I don't know why the power's not showing up. There we go. There we go. Where can we go from here? What is 3 to the third? Well, 3 times 3 is?
9.
Times 3?
27.
27. It's early. It's a very Monday-y Tuesday. And we don't want to math this early. And I get it, but unfortunately, we got to math this early. What do we do now? How can I figure out what x is? Divide by 6. We are almost there. Divided by 6. And we're going to get that x is equal to 4.5. And since we have an x in our argument, we need to double check that we don't wind up with negative arguments or negative bases. So if I substitute this 4.5 in, does this check?
Yes.
Yes, it does. That is the extent we need to do with the check. Ta-da, we checked. There, you're making my check mark be a little brighter. Then what should we do? Or on the next one, what should we do? We just said if we put 4.5 in place of the x here, so if I substitute it back in, would it work? Would we not get any errors? And we only get errors if we have negative bases or if we have negative arguments. So since 4.5 is not negative, it's valid. So we're just watching for negative arguments or negative bases. Negative powers are totally fine. What do we do for e to the 3x equals 27? How do I figure out what that x is? Yeah, we're going to switch this around to its log form. And if you can hop it straight to the ln, love it. Totally fine. I'm going to write one in between step, but it is totally cool to hop straight to the ln on it. But just since it was, a little bit crickety, I'm going to go ahead and do it old school way. So if we switch this to, like with the BPA log BAP, so we have our base of e, that's this guy, our argument of 27, and our power of the 3x, which makes this probably be a little bit brighter. There we go. That's the exact same thing as if we have ln of 27 equals 3x. That log base e is the same thing as ln. They mean the exact same thing. The benefit of having that is ln's a button on the calculator. So ln of 27 is something we can type in. What do we need to do next to try and solve this, though? I want to x equals. Divide by 3. I heard it.
Brain is happy now.
Okay. Love it. So our exact answer here would be that ln of 27 divided by 3 is what x is. Which is all well and good until I want to know how many, years that is. So if we want to get our decimal approximation, our squiggly equal sign, we're going to take our ln of 27 and divide it by 3. What do we get to the nearest 3 decimal places? So thousandths.
I forgot 7.
It does make a difference.
Yeah, it does. 1.099.
Mm-hmm. And we're good to go. That's how we do that's not what I meant to do. Laser pointer. There we go. And that's how we do this. So this would be our exact answer right here. This is our decimal approximation. We do need to be able to find both. We need to be able to find the bougie fanciness, and we need to be able to find the practical decimal. Okay? Questions on this one? I'll do that today. I'll get that posted during first period. Okay. Because we're not going to do any new notes today. It's not. We are also not going to do the test tomorrow. We're pushing it back because we weren't in here. So we're going to do it on Thursday the 17th. Okay. So you guys have 2 days to study for it. I've got the chapter review up here. I've got homework 4 over here. I'll get it in the folder here in just a second. I'm going to pass back the things I have for you guys. It's your time to work, ask questions, get caught up on stuff. We only have one more chapter test after this before we get to finals. So let's make sure this one's a good one. Just saying, because we need a good one before we get to the next chapter, which is kind of hard.
If you can just solve it like this, what's the point of changing it to BPA?
Because on this one, I can't type in log base 3 on my calculator. This one, I can type ln of 27 onto the calculator. That's a button we have. But log base 3 is not a button we have.